Bonjour guys, welcome to my channel. In this video, we're going to do a problem in dynamics. Now, if you guys like this video, don't forget to give us a big thumbs up so that we create more content like this. And don't forget to subscribe and make sure you hit the bell so you get notified each time we post new videos. Now, let's get right into it. So a car is moving along a straight line. We are giving the velocity as a function of time. Initially, the car is at rest and we want to determine the position of the car at 3 seconds. So to solve for this problem, what you guys need to do is find the relationship between velocity and position. Now that relationship is given to you guys on the reference manual. You just have to find it under dynamics section and you're going to have to apply a little bit of calculus to be able to solve this problem. So with that information, why don't you guys give this problem a try, and I will see you in a little bit. Okay guys, so here we are giving the velocity and we want to find the position at 3 seconds. So the first thing we got to do is go to the reference manual and take a look at the equations that we have here. So if we go to the first page, here we are giving these equations which represents the relationship between velocity and position and also acceleration and velocity. Now we are only interested between velocity and the position. So this is the equation we're going to use. Now the only problem is that we're not trying to find the velocity, we're trying to find the position, and we have the velocity. So what we got to do here, instead of taking the derivative, we have to integrate. So let's do that. So this is the equation that we grabbed from the reference manual. The next step is isolate dr because we're trying to find the position at 3 seconds, right? So we're going to have dr is equal to v dt. Now, to get rid of the derivative, we can just take the integral, right? Integrate. So we're going to integrate both terms because if we integrate this term, we have to integrate this term. This term is going to be integrated from 0 to 3. This term is going to be integrated from the initial position, which is r naught, to r, which is the final position, which is at 3 seconds, okay? Now, the next step is let's plug in this function here and then integrate. So we're going to have from 0 to 3 and then 4t to the power of 3 minus 2t squared. And then this is, we're going to multiply by dt and we're going to have equal to dr. Now the integral of dr is just going to be r from r naught to r, right? Now plug in the limits into r, we're going to have r minus r naught. Now the question says that the car is initially at rest, which means this term is going to be 0. So we're just going to have r is equal to this integral. Now to solve this integral, what you guys need to do is use your calculator. So make sure that you guys know how to use your calculator to integrate and to do the derivative. Even though it's actually really easy to integrate this integral, it's still going to take you some time to do it by hand, versus if you use your calculator, it will only take you 30 seconds, and time is very important during the FE exam. So if you are using TI-36X Pro, to plug in this integral in your calculator, all you need to do is hit second and then the e exponential, and then you're going to see the integral there, and then you can enter the 0 to 3, and then you can also enter the function. Now if you guys do that, you're going to get 63 meters. So this is going to be the position of the car at 3 seconds. Now if we take a look at the multiple choice, the answer is going to be C. So that's it guys for today's video. Now if you want more engineering problems or more FE problems, make sure that you guys check out our playlist, and then also make sure that you guys check out our courses that we are offering. They are helping a lot of students pass the FE exam. Now if you guys like this video, don't forget to give us a big thumbs up and make sure that you guys share this video with your friends who might find it helpful, and don't forget to subscribe for new videos every week. Thank you guys for watching. Good luck with your studying and I will see you soon. À la prochaine. Everybody now.